Let's go over this again.
I think we're okay with that particular formula now. How we got the formula, right?
No, you were cut off. Just go over it again.
Okay. So we said X, maybe the question was two elements represented by the letters X and Y have atomic number 9 and 12 respectively. Hence, I wrote this 9 and 12 here. X and Y are the two elements. The question that follows is write the formula of the compound formed when X and Y combines. So how do we write the formula? Is to first of all write out the electronic configuration. Since S has atomic number of 9, configuration will be 2, 7, while Y will be 2, 8, 2. Being the fact that X is a group 7 element, the valency will be -1. Hence, you see writing -1 here because you need one more electron to be stable. Y, on the other hand, is +2. It's a group 2 element. Obviously, it's going to give out that 2 electrons. You see me writing +2 here. Now, the next thing is some students can be so quick and just write it like this. Being the rule is to interchange the what? The valency. So if you bring these two down here and take this one here, it becomes X and then S2Y. Some students will write it like this, but I'll mark it bad. Why is that so? Is because when writing formula of a compound, the metal, which is the cation, is always written first. So I will write it again such a way that I will bring this Y here. I will take this non-metal, which is the X, the other way around. That's why you see me writing it like this. Then I can now interchange. My 1 comes down and my 2 go the other way around. So it becomes Y1. There's only writing the 1, just Y, and the X as 2. So this becomes your formula, YS2. So let the student know this particular aspect. Maybe when we are talking about chemical combination, we'll talk more on it. Right. Is that taken?
Yes, sir.
Okay, thank you very much, Mr. Gabriel. So I think that sorts that out. So I like always using why questions when teaching. So we'll look at all questions under this. I have just 3 more. This time I'm not going to do it. I have 3 participants. I will share it one after the other. Fe2SO4. This is one. COCl2, another, and then the last one. So we have 3 compounds to write out the IUPAC name. So what will it be? The first one. Who can try? I think.
Can we try it now?
Always, yes, we can, but we always say ladies first in everything. So maybe the ladies should start first. Right?
Okay.
No, this was not ladies first.
So this time around, courses should not come into play. We shouldn't do ladies first.
No.
Let's be fair now. Ladies first. Okay. They say anything a man can do, a woman can do better. So let the woman start then. Okay. See, they say ladies should not go first. The guys should go first. So, Mr. Gabriel, maybe you go first. Which one are you going to go with now? Let me do it like this. Mini, money, more. Okay. Mr. Gabriel, take the second one. Since please.
Cobalt chloride.
Okay. Cobalt chloride.
Chloride.
Cobalt chloride. Permit me to do this. Sorry.
Wonderful.
Sorry. Okay. So this is actually this. These 2 belongs to this guy here. So it is
about 2 chloride.
2 chloride. So not cobalt chloride. This. So then for A and C now, The other way around again. Interchanging it, these 3 comes here, these 2 goes to this place. And if the 3 comes here, it becomes what? Ion
3.
Ion 3. Then XO4, what goes here? Remember, this 3 has come here. So where this 2 is. That means these 2 went this way. So I now have SO4, 2 minus. At this point, let me allow you to calculate the oscillation number of X for me here. Auntie, don't do R now. You can do it now. It said P is in you, like that advert. So, XO4, 2 minus. You're looking for oscillation number of S, which is sulfur in this radical. Okay, that is X bracket minus 2 times 4 equals to
6. 6.
okay, that should be 6. So that will not be ion 3 tetra also sulfate 6. That's the name of this one.
Okay.
So why can be so tricky? This is why question. Some students will go and say it is ion 2 because of this 2 that is here. So, then for this, if you do your crisscross rule again, 2 comes here, and the visible 1 goes here. So that means NO3 is NO3 minus. Looking for oscillation number of N, it is what?
5.
5. Okay. So some students will go and say magnesium 2. They're not like magnesium 2. Yeah. All these ones are putting cobalt 2, ion 2. Those ones are the ones that have 2 or 3 oxidation states. That is more or less like they are 2 phases. Some people, they are smiling in the morning, in the night they are frowning their face. Some persons are just smiling all through, even if you like cause them for not to know. That's how their face is. So that means they have only 1 oxidation state. This magnesium have only 1 oxidation state. So these 2 here that we brought here was just for calculation sake. So magnesium still remains magnesium. It's not like magnesium 2. So the name becomes magnesium triazo nitrate 5. That is for this. Any more questions? Any question? Can I continue?
Yes, sir.
Okay. So, thank you very much for your attention and time. I think I did that one together because until we all get it right, I will not go to the next thing. That's how I do my own. So if you are okay with this one, then we can move on. So can we name this? If not the second one, maybe the second one should be simple now. If not the first one, Madam Mufoma, please help us. Name the second one, please. Try. There's no R in trial, like we always say.
Potassium.
Yes, thank you. Go on.
Potassium tetrazo manganese.
Yes, I'm interested in that part. The manganate or manganese?
Oh. Manganese.
Okay, manganese. Let's continue first. We'll come back and visit that part. Manganate what?
I think I hooked there.
You hooked there. No hook. You can continue. What is the oxidation number for potassium?
1.
+1.
Okay.
Plus
Oxygen.
1
Oxygen, when it's in a compound.
is -2.
Okay, let's read this way. -2 times 4.
times 4, that is 8 minus 8.
Okay, forget about the minus. 2 times 4.
8,
8 minus 1.
7.
So the manganese is 7.
Oh,
Hmm? Yeah. So that would be potassium tetraozo. Manganate 7. Not manganese. Because the symbol Mn is manganese on its own. So it will be manganate 7. Any question? Are we there?
Nope. Yes,
yes,
we
we
are
are
there.
here.
Okay, then the last one will be what? This one is
Copper
different.
2,
This one is different.
copper 2,
Mhm.
Okay, copper 2, yes, go on.
tetraozo sulfate 6,
Okay, go on.
pentahydrate.
Okay, there's a dot here. This compound is an hydrated
Hydrated
compound. Hydrated in the sense that it contains water of crystallization. So hence, if you are to name CuSO4 on its own, it's called copper 2 tetraozo sulfate 6. I'm sure nobody has issue with that one. The aspect
Yes.
here is this dot 5H2O. 5 is penta, like a pentagon, a polygon with 5 sides. Then, because of this water, it is called hydrate. So it is pentahydrate. So it is copper 2 tetraozo sulfate 6 pentahydrate. That is the name of this compound. Madam Esther, do you understand?
Yes, sir.
Okay, thank you very much. So I want you to give me the formula of this compound. Potassium heptaoxo dichromate 6. Is that taken? Did you get it?
Yes,
no,
sir.
no.
Okay, I come again. What is the formula for the compound potassium heptaoxo dichromate 6? Potassium heptaoxo dichromate 6.
Potassium, beta.
Potassium heptaoxo dichromate 6. So in case you don't get it, that's the spelling on the board.
Okay.
Okay.
K2.
Yes, thank you. I'm hearing K2. Can we continue with that?
CR2.
K2, CR2.
07.
07. Perfect.
Affirmation.
So I can gladly say I am done with writing formula of the compound and how you part nomenclature, since we have been able to successfully answer one. Anybody has issue with how we got the name? So we just okay. The next we are supposed to look at now is formula or laws of chemical combination. Laws of chemical combination. Basically, there are 3 laws. Laws of chemical combination. There are 3 laws: law of constant composition, law of definite proportion, and law of multiple proportion. Those are the 3 laws. Law of constant conservation of mass, law of definite proportion, and law of multiple proportion. Is that taken?
Yes, sir.
Okay. So for the first law, the focus here is I want us to be able to teach the students how to solve questions and interpret it based on the laws. So I won't be dwelling more on stating the laws. However, sometimes they used to ask them to state the law in theory. Maybe let me just state it quickly, run it through it. The first one, which is law of conservation of mass, states that matter can neither be created nor destroyed, but can be converted from one form to another. And states that matter can neither be created nor destroyed, but can be converted from one form to another. Is that okay?
Yes, sir.
Okay. Let's look at one example under that. Example. In an experiment, 5.0 gram of calcium triosocarbonate 4. Now you can use formula now because we know how to write formula. I will not be giving you the formula anymore. In an experiment, 5.0 gram of calcium triosocarbonate 4. Are we there?
Yes.
On
Yes, sir.
eating, not you eating something. When you apply fire, that's the eating I'm talking about. HEATING. On eating gave 2.8 gram of calcium oxide. On eating gave 2.8 gram of calcium oxide and 2.2 gram of carbon 4 oxide. Is that it?
Yes, sir.
Full stop. Show that these results are in accordance to the law of conservation of mass. Show that these results are in accordance to the law of conservation of mass. Show that these results are in accordance to the law of conservation of mass. So when teaching this aspect, they need to understand, okay, now let's do it together. What is the compound that was heated?
CaCO3.
Okay, CaCO3. And upon heating CaCO3, gave us what?
CaO and CO2.
Okay, CaO and CO2. Perfect. Is the equation balanced?
Yes.
Okay. If the equation is balanced, what was the mass of CaCO3 as given in the question?
5.0.
Okay, this is mass of reactant. Mass of reactant. And the products, CaO is what in terms of mass?
2.8.
2.8 gram. And CO2, 2.2 gram. This is mass of products. They now ask us to show that this result is in accordance to the law of conservation of mass. And that law simply states that matter can neither be created nor destroyed, but can only be converted from one form to another. That means this compound now, which is your limestone, has only been converted from limestone to calcium oxide and carbon 4 oxide. So what we are going to do here, that law simply tell me that my mass of reactant should be equal to mass of products. That is what that law says, because matter is not created. You're only destroying it, or rather, it's not destroyed, rather, you're only creating it from one form to another. So if we add up this, it should give me 5.0 gram. Why my reactant still give me 5.0 gram? Since there is no change in mass of the reactant and product form, it is in accordance to the law. That is just the answer.
Wow.
Any question? Do you have any question on this?
No, no question.
Okay, very simple now. I said there's no time to, we won't waste time here. Then let's quickly look at another law. Law of definite proportion. Law of definite proportion. Are we ready?
Yes.
Yes, sir.
Okay. It states that all pure sample of a compound, are combined in a fixed proportion by mass. It states that all pure sample of a compound are combined in a fixed proportion by mass. All pure sample of a compound are combined in a fixed proportion by mass. That taken. This law is also known as law of constant composition. This law is also known as law of constant composition. That taken. Any question? I know we are getting tired. Do we round it up now? Do we call it a day here?
Sorry. Sorry, sir. Is it law of constant?
Composition. This law is also known as law of constant composition.
Okay.
So in case you see some textbook will put it as law of definite proportion, some textbook will also call it law of constant composition. They are the same thing.
Okay.
Example. Let me just look at one example under this. Are we ready?
Yes, sir.
Yes, sir.
Okay. In an experiment, 0.2430 gram. In an experiment, 0.2430 gram of magnesium on burning with oxygen, 0.2430 gram of magnesium on burning with oxygen yielded 0.4030, that is 0.4030 gram of magnesium oxide. Full stop.
0.40.
30 gram of magnesium oxide. Is that taken?
Yes.
Okay. Full stop. In another experiment, comma. In another experiment. Can I continue?
Yes, sir.
Yes.
0.1820, 1820 gram. 0.1820 gram of magnesium on burning with oxygen. 0.1820 gram of magnesium on burning with oxygen yielded 0.3020 gram of magnesium oxide. Yielded 0.3020 gram of magnesium oxide. Full stop. Show that the data explains the law of definite proportion. Show that the data explains the law of definite proportion. Show that the data explains the law of definite proportion. These are theory questions. But over the years, I don't know why it's just so fortunate that our schools, the government schools, they don't really pay attention to JAM. These questions are mostly in JAM questions. You hardly see it in WAEC, but it would be nice when we are teaching. If only if I have my way, I would have suggested to them, let them try as much as possible to harmonize the scheme to include WAEC, JAM. Most of our scheme are too watery, and just very, very shallow things. That's what we teach them, which is not actually fair on the student. That's why you see most of our students don't do well when it comes to JAM because of the nature of the scheme. However, what do we do? Are we ready? Let's quickly look at this. Are you with me?
Yes, well.
Okay, sorry. I think after this, I will round up because from the voice, it looks like law of diminishing returns is setting in. So we have two experiments. I'll do it this way.
Sorry, we didn't finish the question before the thing went off.
Really? You were the one that went off. Where did you stop? Where did you stop?
Okay. The second part where it said oxygen yielded
In another
0 point.
experiment,
Yes.
0.1820 gram of magnesium
Yes, with
on
oxygen.
burning with oxygen yielded 0.3020 gram of magnesium oxide. Yielded 0.30 gram of magnesium oxide.
Okay.
Show that the data explains the law of definite proportion. Show that the data explains the law of definite proportion. So, like I said, this I will do it. Since we have two experiments, I'll put experiment 1, experiment 2. Are you with me?
Yes, sir.
Okay, in experiment 1, we have magnesium and we have oxygen. In experiment 2, we also have magnesium and oxygen. Both are the components that was there. However, both experiments also yielded magnesium oxide. If you join magnesium oxide is MgO, so that will not come into play here, but we'll get to that aspect. What is the mass of magnesium in the question? Experiment 1.
0.243.
0.43.
So I'll put 0.243. Does it have 0? Is it 3 decimal places or 2 decimal or 4 decimal places?
3 decimal place.
It's 4. 2, 40, 30. It's a 0 at the end. Gram.
Okay.
Then moving further there in that same question, they now said yielded what?
0.4030 of magnesium oxide.
Good. Now, when they say yielded that mass of magnesium oxide, to get the mass of oxygen, it will be 0.4030 minus 0.2430. That means I want to get the mass of oxygen because it yielded. That means magnesium oxide put together was this mass. So what then is the mass of oxygen? That's why I need to do this subtraction. Hope we understand.
Yes, sir.
So if you do that subtraction, what do we have? Quickly, if you have the calculator nearby there, you can help us. So this should be 0.2430. I think I should be having 0.1600. 00.
0.1600.
Gram. Gram. Any question? The next thing is looking at the two. What is the smallest of the two values?
0.1600.
So we divide by this smallest, 1600, 1600. This should automatically give me 1. And this should give me, you have the calculator, help us. 2.243 divided by 0.1600. It should be
1.5187.
Maybe we can leave it to to the nearest whole number. That should be
2.
That should be 2. With the nearest whole number, that should be 2. So it is, the ratio is 2 to 1. I'm running out of time. So we'll go to experiment 2. Let's see experiment 2. What is the mass of magnesium in experiment 2?
0.1820.
Okay, 0.1820. Then they said yielded a certain mass of magnesium oxide. So to get oxygen, it will be the mass yielded minus the mass of magnesium, which is what?
0.3020 minus
0.3020 minus 0.1820. This should still give me 180. Sorry, 20. So
0.12. 0.1200.
0.1200. Okay. So we divide again by the smallest. Divided by the smallest, 0.1200. 0.1200. This should give me 1. Divide this, what do we have?
2 to the nearest whole number.
The nearest whole number, 2.
2.
Yeah. So this since in experiments 1 and 2, the ratios are the same, it is in accordance to that law. That is just the answer. So,
Wow.
so I wish when I was having here 1 to 2 and I'm having here 1 to 4, it will be multiple proportion because there's no time anymore. It will be law of multiple proportion. But since both ratios are the same, you will now say that the experiment is in accordance with the law of constant composition or definite proportion, irrespective of the method that was used. Yeah, so that's just it. It's just like you're getting water from Asaba now, and the water from your location. Water still remains water. The chemical formula of water still remains H2O, irrespective of where you get it from. So that is what the law is talking about. That all pure samples are contained in a fixed proportion by mass. I think at this point we could call it a day. Any question before we shut down? There was no time to look at law of multiple proportion. Otherwise, we will have looked at that. But you can just.
There's one question I wanted to ask before.
Okay, go
on. So I want to know when, if we're writing the formula, when are we to use? When are we to use ATE?
ATE.
OUS. Yes, OUS and ITE or IDE. Yeah, I think those 4.
Okay, IDE.
No, this is basically ITE, then ATE. Okay. Yes, I think those 3.
Okay. IDE, that is an oxide, like nitrogen 4 oxide. And ATE, for example, tetraoxomanganate. When you are looking for ATE, has to do with when it is 3 elements. That is obviously the one in the middle. IDE, it is when it is 2 elements, like NO2, SO2, nitrogen 4 oxide, sulfur 4 oxide, like that. Then ITE, I don't think I've seen any compound that has to do with ITE, but let me crack my head if I can just bring out one. But I think I haven't come across any compound with ITE. But if you have any one, you can just give me the name. I'll tell you on which down to the name. I don't think I've come across institution by end with ITE.
Something I really don't know. That's what I'm moving to ask yourself. But the thing is, something I usually compare these like phosphorus or nitrogen. You know, we can have nitride, nitrate, nitrite, or phosphate, phosphide, phosphite. So I really don't know which one will be their formula in that case.
Then maybe oxide like that. So if you are using IDE, that means it's of sulfur or sulfate. Sulfide, like you see now, they are all IDE. That means it contains oxygen. Then if it's nitrate, that means the compound is a 3 element, whereby the one that is having the ATE attached to the name is the element in the middle.
Okay.
Like in the case of maybe K2, Cr2, potassium heptaoxodichromate.
Okay.
Like that. But anyone that has to do with IDE is mostly an oxide. It contains oxygen.
All right. Perfect. Thank you, sir.
You're welcome. Any other questions? So it's all done.
No, sir, no other question.
Okay, so we'll see again. So just for the sake of those who are not here, maybe I'll just put the link. I can't upload this, but I realized the last time I did, most persons were not actually watching, so I'll upload it on my YouTube channel. Those who care to watch can always watch it for there. I'll put the link to the channel there. So that's the best we could do for those who were not able to hook up. So it was nice having your time, and thank you very much for making our time for this. We'll do this again on Wednesday.
Thank you very much for having us.
Thank you so much.
Welcome. See you.
All right, take care.